Morning, lads. Happy Friday. Apologies for the late post. I had a video created and I had it uploaded. For some reason it's not working for me, so I had to redo this one this morning. Okay, so we're on page 144. We're going to fly through this, lads. It won't take too long, okay? And then when you come back to school, you'll actually be doing this and the project and want to get back into the classroom. So just to run through a few things, all right? So the first thing is, when you have the electronic components like you've seen here the last day on the, now we didn't use a breadboard because it's meant to be a classroom activity and you don't have breadboards at home. Not the type of breadboard you cut your bread on home. They're slightly different. So the last day you looked at these kind of circuits, all right? Now, this circuit is all done obviously on a software. You drew it out and everything's connected properly. And here's your joints, that all your solder joints essentially, that they're connected together. Now, if we're sitting in a classroom, you have to keep these wires together in some way. Otherwise, they're just going to keep falling off the connectors. So when you connect the switch to a bulb, you use wires to do that, obviously. But obviously, you need to keep them wires in place permanently. You don't want them coming off, getting loose. If someone touches you, you don't want the wire falling out. So what we do is we solder everything in place. Now, you've seen this in Unit 5. It's soft solder. And soft solder is basically used to join electronic components together. The reason it's used and why it's used in electronics is because it's conductive material. What it means by that, and going back to your properties materials, which you've seen previously, a conductor allows electricity to flow through it. Conductive material also allows heat to flow through it. So this is called a conductive material because obviously it allows electricity to flow through it, and it doesn't affect the performance of the electric circuit when it's all joined together. So that's essentially all you need to know. What you need, a few other things that you need, might get you to highlight for me, is that solder is obviously an alloy. And an alloy, just going to recap on what you looked at previously, an alloy is a mixture of two or more metals. So you have tin and you have lead, two separate non-ferrous metals. You push them together, which is not possible. So we don't push them together. We heat them up and we melt them down. And when they solidify again, when it gets solid again, when they're mixed together, it gives you solder. Now, solder is a soft material. It's quite soft. You can pull it in your hands and you can break it in your hands, and has a low melting point. Okay, so if you want to write after this, a melting point of solder is 183 degrees Celsius. And if you think of it, water boils at 100 degrees Celsius, so another additional 83 degrees Celsius, and you can melt an actual metal. And this metal, or alloy, you want to call alloy metal, is solder. Okay, and that's pretty much all you need to know there. There's not much more you need to worry about there. The next thing you need is a soldering iron. The soldering iron, as you can see in the picture here, is held using your index finger and your thumb. And it's pretty much the same way you hold a pen, and that's just to give you control. If you hold it just gripping it in your hand like you grip a hurl, then obviously you have no control over the soldering iron. And because this heats anywhere from between 200 to 300 degrees Celsius, it's extremely hot. This part down here heats up. The rubber part up here is an insulator, obviously an insulator, because you don't want your hand touching a hot soldering iron, it would burn you. So therefore the soldering iron needs to be held like a pencil. So we need to use this in order to melt the metal above it, the solder. So we melt it using the tip of it here. That's all you need to know about that. The next thing, if you make a mistake when you're soldering, we all make mistakes, sometimes you need to take desolder a joint. So for instance, if you solder switched a wire in the wrong way, you made a mistake, you put it in the wrong place, you can desolder. Desolder means you're taking away the solder you put on. Now this thing here is called a desoldering pump, a vacuum pump. The way it is here, if you press this button down as far as here, okay, it traps air inside the cylinder inside here. And if you press a button here, it just releases air and sucks up the solder like a vacuum. All right, so you can suck the solder out of a joint. And again, you'll see that in the classroom. And then the last thing you need to know is wire strippers. Wire strippers essentially strip wires. If you look at a cable, and any cable in your house, you'll see that there's a coating over it. It's got a plastic coating over it, so you can't physically see the cables. So we use these wire strippers to strip back that coating, so in order to see the wires on the inside. Anyone who's done technology will be familiar with this. And is also used to cut the wire. So if you look in here, there's a little section, a little V in here, you put the wire inside there, if you squeeze the handles together, it cuts the wire. So this is your wire cutter, and this little thing up here where you see a little mouth, it looks like a dinosaur's mouth. If you put the wire inside here and you squeeze the hand again, it just closes these jaws and it strips the wire back for you. So it exposes the wire that you need to see. Again, I'm not too worried about that. I just want you to be familiar with what they look like for now, and I'll be extremely happy with that. Okay. The soldering process, guys, again, there's not really much point going through this because if you're in a classroom, it's much easier to do it, but I'll run through it quickly, all right? So you have your solder coming on here. Here's an example of a switch that you would look a single pole, single throw. Excuse me. And this here is a resistor, okay, which you've looked at the last few days. So what happens is you put the resistor, the wire of the resistor, into the hole here in the switch. You put your soldering iron on the terminal block here on the switch, and you push in your solder, and the solder starts to melt. So you heat up the junction, so you heat up the joint here, so your wires come through this little hole here, and then you kind of wrap it around it so just the resistor doesn't fall out. You push your soldering iron into the joint, and then you push your solder on top of it. And because of heat of the little block here or little terminal on the switch, the solder just starts to melt naturally. You lift away the soldering joint, you lift away the solder, and it starts to solidify and gets hard here. Okay, and then you have a permanent joint. Okay, now there's a few things in terms of safety. We have a thing called soldering stands, and I'm just going to Google so you can see it. We use these always. We don't leave the soldering iron sitting on the desk. Soldering iron stand, and it looks like this. Whenever that's what we use here. So we use a soldering iron stand to hold the soldering iron when we're not using it. You got to be careful that you don't leave. If I go back, if I go to type in here soldering iron, just you got to be careful if you're not the cable of the soldering iron. See the cable here, the soldering iron, that the tip of it's not lying against it anymore. Some kids make that mistake and it just burns the cable and the soldering iron is gone. It's no good anymore. So if you leave the soldering iron lying on the cable, it burns the cable, and it means then you can't use the soldering anymore. So you got to be careful that the cable is not near the soldering iron tip. Excuse me, I apologize. The next thing is you got to work in a well ventilated area. Now, technically, solder is made from a poisonous material. You've got lead and tin. They're trying to eliminate lead used in materials now because lead's quite a poisonous material. Now, the amount of lead that's in solder is very minimal. It's not going to cause us any harm, but we need to work in a well ventilated area anyway, regardless. So our engineering room in the school is very well ventilated. It's got back doors, it's got vents in the ceiling, so it's well ventilated. So we don't need to worry too much about that. If you're working in a confined space, like a really tight space, you would need to wear a face mask just to protect, like the mask you're wearing now when you're out and about, to protect your lungs essentially. Okay. That's pretty much it in the chapter, guys. All right. What I'd like you to do for me today is to do some of these. Now, these are research activities, and you're going to need. You can use look back through your previous chapters. All right. What I'd like you to do is choose an existing mechatronic device. Now, this could be anything. This could be any mechatronic device because electronics mechanisms could be TV could because there's a fan in it. Your PlayStations, your microwaves, your dishwashers. So research any device and describe the device under the following heading. So name the device, sketch what it looks like, what's the device intended for, and describe the device functions as a mechatronic system. What it means by that, how do you think it works, as in like in your own words, so what electronics things inside it, just from what you know so far. What mechatronics is inside it, so what mechanisms is inside it, what electronics is inside it, and then how do you think it all works? All right, so we're looking for a little bit of detail here, hence the 3 lines. Describe particular aspects of the design that you like and why. So thinking of the design part of it, relating back to the design photo frames, you're all thinking about design and improving. Describe what aspect of the design that you like and why. And finally, describe particular aspects of the design that you can improve. So what part of that project or what part of that mechatronic device that you have that you don't like? How could you improve it? Okay. The next thing is then we'd like you to look up inventors on your phone. So research who invented the World Wide Web. So who invented the internet essentially, and then write down 3 key facts about this inventor. Now, the 3 key facts is obviously would be where he was born, his date of birth, when he died, and what else did he invent. Okay, so this is getting into the habit of researching inventors, and this is part of the engineering process now. And then finally, no, we're going to leave this too long. It's way too long. You're going to leave that because you only have a single period. Okay, so just you're going to do research activity 1 and 2 on page 145, and then you're going to highlight the few bits of theory on this little bit of page here. And that's that unit done. So you have no more theory to do this year. I'm not introducing you to any more theory this year. You're just going to be doing practical when you go back to school. And then the next few weeks, I have a few little tasks for you to do for me. Some of it's in the microbit, and then there's the cardboard task as well. That's it, lads. Have a lovely weekend, and I'll chat to you on Tuesday for a live lesson.